So in which of the following process both the cycles have at least one isothermal process? Is it diesel, Otto, or Carnot, Stirling, Brayton, Rankine, Bell-Coleman, vapor compression, refrigeration cycle, etc. So let us analyze each of these options. The first choice what they have asked is diesel cycle. So diesel cycle, diesel cycle. Let's draw the PV diagram and the TS diagram. So on x-axis we have volume, y-axis we have pressure. Let's draw the PV diagram. So this is the PV diagram of a diesel cycle. So this is 1, 2, 3, 4, 1 to 2, 2 to 3, 3 to 4. So this is the heat addition process and this one is the heat rejection process. So process 1 to 2 is isentropic is equal to constant, 2 to 3 is pressure equal to constant, 3 to 4 is again S equal to constant, and 4 to 1 is volume equal to constant. Let's draw this on the TS diagram also. So in TS diagram it will look something like this. TS, this is 1 to 2, 1, 2, 3, 4. Heat addition, heat rejection. So 1 to 2 is S equal to constant entropy process, 2 to 3 is constant pressure process, 3 to 4 is isentropic process again, 4 to 1 is constant volume heat rejection process. So this is diesel cycle. So let's move on to next cycle, which is the Otto cycle. Otto cycle. Again, let's draw the PV and TS diagram. So this is the PV diagram. So in Otto cycle we have 1, 2, 3 and 4. So here this is heat rejection and this is heat addition, heat supply. So let's draw it on the TS plot. So let's draw the TS diagram here. So 1, 2, 3 and 4, 1, 2, 3, 4. This is TS diagram. So for Otto cycle 1 to 2 is isentropic process here, 1 to 2 is a straight line, and 2 to 3 is constant volume process here, constant volume process. So 3 to 4 is again S equal to constant, and 4 to 1 is again volume equal to constant. Now let's go to Carnot cycle. Now Carnot cycle. In Carnot cycle, the TS diagram is, so there is, it looks like this. So this is TS 1, 2, 3, 4. So 2, 3, 3, 4. Here heat addition, heat rejection. So basically there are two isothermal process in Carnot cycle. So 2 to 3 is again temperature equal to constant isothermal process, and 4 to 1 is again T equal to constant. Now similarly let's next try Stirling cycle. Stirling cycle. So our choice Carnot cycle matches the required answer. Now let's study what is Stirling cycle. In Stirling cycle we have, it looks similar to Otto cycle. This is P and V. So 1, 2, 3 and 4. So over this 3 to 4 is constant temperature process, and 1 to 2 is also constant temperature process. So in TS diagram, let's plot it. It will look like this. This is T, this is S. So let's start with 1, 2, 3 and 4. So 1 to 2 is same, it is same as constant volume process. 1 to 2 is constant volume process. 3 to 4 is again constant volume process. 1 to 2, sorry, 2 to 3 is constant volume process. 2 to 3, this is constant volume. 1 to 2 is constant temperature, temperature is constant. 3 to 4 is again temperature is constant. 2 to 3 is volume equal to constant. 3 to 4 is temperature equal to constant, and 4 to 1 is again volume equal to constant. So again there are Stirling cycle means Stirling cycle has 2 isothermal process and 2 isochoric process. Now let's see what is Brayton cycle. Brayton cycle is ideal cycle for gas turbine engine. So quickly let's draw the TS diagram. So TS diagram looks like this. Here this is T, this is S, this is 1, 2, 3, 4. So 1 to 2 is the compressor, compression or isentropic process. 2 to 3 is constant pressure process or heat addition. 3 to 4 is the turbine, and 4 to 1 is heat rejection, which is again constant pressure process. Now let's study the Rankine cycle. Rankine cycle. So Rankine cycle is the ideal cycle for steam power plant, where steam is the working fluid. So again on TS diagram, let's quickly draw the TS diagram. So this is T, this is S. So it will be 1, 2, 3 and 4 here. So this is turbine, and this one is 3 to 4 is the boiler, and 1 to 2 is the condenser, and 2 to 3 is the pump. So in here the process is 1 to 2 is again or 1 to 2 is constant pressure. 2 to 3 3 to 4 and 4 to 1. 4 to 1 is S equal to constant. Then 3 to 4 is the boiling process, and which is again done constant pressure. And so next is the BELL-COLEMAN cycle. BELL-COLEMAN cycle is basically for air refrigeration system. Air refrigeration cycle. So the TS diagram is TS. So since this refrigeration cycle, the direction of the arrow should be in anti-clockwise. So 1 to 2 is again s equal to constant, should be straight line. S equal to constant. 2 to 3 is p equal to constant. 3 to 4 is again s equal to constant, and 4 to 1 is p equal to constant. And final option what they have asked is vapor compression refrigeration system. So vapor compression refrigeration system or VCRS. So the TS diagram for VCRS cycle is, so 1 to 2, this is 1, 2, 3 and 4. So TS 1 to 2 is equal to constant, 2 to 3 is the condensation process, P equal to constant, and 3 to 4 is isenthalpic process, and 4 to 1 is equal to P equal to constant. So basically this is 1 to 2 is compressor. So let's write using this. This is compressor. So this one is condenser, and 3 to 4 is the expansion process, expansion valve, and 4 to 1 is the evaporator. So let's go to the choice again. VCRS, BELL-COLEMAN cycle we have identified, BRAYTON cycle, RANKINE cycle. So STIRLING cycle has 2 isothermal and 2 isocoric process, and even CARNOT cycle has 2 isothermal process. So basically the right answer is B, CARNOT cycle and STIRLING cycle.